Let's review gravitational field strength. The symbol for gravitational force is F for force, subscript G for gravitational force, and that's the force that the Earth or some other planet pulls down on an object. We call that the gravitational force, but that's also synonymous with weight. The Earth pulls on me with 175 pounds of force, and that is my weight. So please remember that. In class, we took mass measured in kilograms and put it on a scale and measured the force on the spring scale due to the mass in newtons, and made a graph of gravitational force versus mass and came out with a slope, and the accepted slope for such a plot is 9.8 newtons per kilogram, which means for every 1 kilogram of mass on Earth, there will be 9.8 newtons of gravitational force pulling it down. So we say the gravitational field strength on Earth is 9.8 newtons per kilogram. This value is particular to Earth. On the Moon, its gravitational field strength is weaker because the Moon has less mass, and it's 1.6 newtons per kilogram. On Mercury, it's 3.78, and so on. From the activity in class, we derived an equation that relates gravitational force to mass, and the slope of our graph was the gravitational field strength G. So we have a general formula for any situation that says gravitational field strength equals the mass times the gravitational field strength. Since gravitational field strength is the same as weight, this formula can be written with a W for gravitational field strength instead. So W equals mass times gravitational field strength. If we rearrange this formula, we can solve for mass. Mass would equal the weight divided by gravitational field strength. And gravitational field strength would equal the weight of an object divided by its mass. On this handout, we have this first problem. It says a record largemouth bass was caught in Georgia. Its mass was 10.15 kilograms, and it's asking us for the weight. Well, we have the mass. We're being asked for the weight, question mark. Georgia means it's on Earth, so we know that G equals 9.8 newtons per kilogram. So let's just use the simple relationship shown above. Weight equals mass times gravitational field strength. In this case, 10.15 kilograms of mass times 9.8 newtons per kilogram is G for Earth, and that's equal to the weight, and that equals 99.47 kilograms cancel, and we're left with newtons. So the weight of this largemouth bass caught in Georgia in 1932 was 99.47 newtons. The next question says, what if that fish is taken to Mars? What will be its weight in newtons on Mars? Well, same calculation. The mass of the fish is the same. Mass is the amount of matter in an object, and it's going to be the same on Earth as it is anywhere else in the universe. So that's the same as was given up here. But the gravitational field strength on Mars is 3.72 newtons per kilogram. So the product of mass and gravitational field strength gives this weight for the fish on Mars, 37.76 newtons. This next one asks what's the mass of the fish in kilograms on Mars. Well, if you realize the mass of an object does not change no matter where you are in the universe, then you can just simply write down the given mass as the mass on Mars, because that is the answer. If you were to try to calculate it, we want to divide the weight of the fish divided by the gravitational field strength, and we'd have to pick one of those planets. Let's pick Mars. The weight we just calculated was 37.76 newtons, and the gravitational field strength on Mars is 3.72 newtons per kilogram, and that will give us 10.15 kilograms as the mass. It just shows the math works out, but you should know that the mass of an object will not change no matter where it is in the universe. So it's simple enough just to write that down.